right, welcome everyone. Thank you for attending our session today. We're going to talk a little bit about Ford Motor Company's acceleration to cloud. And my name is Todd Hall. I'm head of developer relations at Ford Motor Company. I lead a team of developer enablement members, and our focus is on helping optimize and accelerate the way software development is done at Ford, especially for cloud systems. I'm going to be joined on stage in a little bit by my friends from Google, the three J's, as I like to refer to them, so somehow I don't match the others here, but they each will come up and share a little bit about the Google products that we all leverage. So to get started, I'm going to talk about Ford's acceleration mission. And in case people haven't heard of Ford Motor Company, I like to think everyone's seen the blue oval, so everyone knows who Ford is, but maybe you don't know all of the details. And this is a little bit of bragging, but it's a little bit of letting you know the scope and scale of what we have at Ford Motor Company. So there's 177,000 employees worldwide. We sold just about 2 million vehicles last year, and we have roughly 20,000 software engineers. So that number makes me really happy as a software engineer at heart. So you can see Ford is really big on software, and it's a key aspect of what we do. So much so that per our corporate website, you know, you think we're going to be bragging about we're a 20-year-old company. We sell a lot of vehicles, but we also talk about an emphasis on software, services, experiences. So it's great as a Ford employee to see that, yep, vehicles are at the core, but at the same time, technology is super, super important to us and is key to us being able to accelerate our goals. So as I get started, I'm going to talk a little bit about the technology at Ford and our journey. So we have a really, really diverse set of technology, as you can imagine. Lots of programming languages, lots of platforms, stacks, frameworks. Sounds kind of chaotic, but a lot of commonization as well. So people like myself who are part of our enterprise architecture organization, we like some standardization and commonization, of course. So a little bit of kind of history going back. I like to think of the web era. What did that look like at Ford? Lots of app servers, these big monolithic applications, stateful, running in data centers. I'm sure all of you have these sitting around your enterprises. So that's what business systems look like. Those systems relied on, again, relational databases, big database farms, housing a lot of our core business data. These are all managed by shared DBAs as well. So from a developer experience, kind of tough. And my last bullet there, what am I really saying here is that, hey, this, you know, it was good at its point in time, but low agility, slow to update these apps, slow to update databases, manual approval processes. Scaling was a manual process and involved a whole lot of paperwork and meetings, none of which software developers enjoy. So, you know, it was a challenge. So let's move forward a little bit and talk about, all right, we modernized a bit, the cloud era comes, we're on this path to cloud, but really we were still in our corporate data centers, but really focused more on cloud native architecture. So to me, that's these stateless cloud native apps, 12-factor, if you've heard of that term. So that gives us a lot of the abilities of cloud. But again, Ford data centers. Microservice architecture, I mean, the picture clearly is what most of you are familiar with of microservice architecture. The UI experiences now are detached. We're running lots of web front-end stuff, JavaScript frameworks. Again, very common patterns. And of course, this meant embracing API-centric architectures as well. So lots of APIs. These apps are hosting one-to-many APIs, and that gives us the flexibility of composing all of these experiences It can be for system type applications or your classic web apps where your UI is the consumer of your API. So this was all foundational work as we move to really the acceleration to true cloud or public cloud. So where we're at today, we have tons of applications, right? So we are actively moving our applications to the cloud, applications and data services, getting them out of the data center. And of course, we got this legacy footprint or apps that we've already had, but we're also doing greenfield, of course. So lots of new apps. Now we have this well-established pattern of how we get to cloud with our new apps. Don't add any more technical debt to the pile. With this shift or evolution was introduction of containerization. So primarily when we were running these cloud native apps, they were in platforms as a service, not true container platforms. So now, hey, let's really focus on containerization. Let's leverage managed services or serverless in the cloud. And that was strategically done as an effort to ease the complexity a bit. We're not going to jump all the way to Kubernetes. We do some Kubernetes, but our talk today is really about managed and serverless. So that was intentional. Let's not bite off more than we can chew and keep the complexity as low as possible. But we weren't done here, so we made this strategic decision to go cloud. But there's more work to be done. We have been working on optimizing what the cloud experience is, improve how we do scaling, think of the cold start problems we have with some of our legacy apps, batch use cases. So anyone who's got legacy software, it's not all real-time systems, lots of batch. How do we get that work in the cloud environment? So all of these types of concerns are things we're still tackling as we evolve. And part of that evolution, so we defined where we want to go. Now let's talk about how we defined what we termed our opinionated stack. It's really about patterns and acceleration. So we created our opinionated stack. It was a collaborative effort, several teams inside of Ford, my team being part of enterprise architecture, our colleagues from enterprise platform engineering and operations, got together and said, okay, what do we want an app to look like in the cloud? And we defined this opinionated stack in terms of 15 elements. So these elements cover things like application architecture, infrastructure, and cloud services, even development tooling. So let's get the thought leaders, the subject matter experts within the company to define how we want these things to look like, or what we want them to even be. So it's compute, databases, pipelines, containers, secrets management tools. I mean, all of these things, monitoring and alerting, all important things that we want every app going to the cloud to utilize. Furthermore, we want them to be used in a consistent way so that not everyone's having to figure it out, and better yet, it's figured out for them and it's done in compliance with the way we would like it done, or better yet, the way security would like these things done. So, so having it as a definition, it isn't going far enough. So of course, we would like to automate everything. As engineers, automation is king. So we decided to take this opinionated stack and automate it in our self-service provisioning portal, which I'll show a slide of in a moment. But with the goal here of, let's take this definition, codify it, and allow it to be replicated through automation. So at the end of the day, you get your app, a new infrastructure or a project in the cloud, pipelines, all the development tools, all wired together and configured so that, and configured in minutes so that you, the development team, can get to doing the real thing you're supposed to be doing, delivering business value, writing code that solves business problems. So here's a little picture that hopefully does a better job of describing it than I did. But after automation is utilized, we lay down these elements that gives you I'll say, a way to comply with our definition. And at the end of the day, we're like what I like to term it as, we hand you the keys and you're on your own now. So you have repos. We've given you commit one in these repos, whether it's infrastructure as code or real application code. Commit 2 is yours, and commit 2 will be delivered to an environment via pipeline. So you can see better that we're giving you the pipeline, app code, static and dynamic application tooling, all the pieces of the cloud, whether you need serverless, messaging, caching, and the like, and logging and monitoring. So this is what it looks like when it's really laid down, and we walk away and let the teams go do great work. So with that, I talked about the self-provisioning portal. We call it the Ford Cloud Portal. This is the place that teams go to provision their environments. And maybe it sounds like a simple thing, but we hate tickets. Let's get rid of tickets. This was a great move forward for us to allow this all to be done and meet the teams when and where they need to do it. So kind of an eye chart, but showing one page here for our opinionated stack. And I don't know if you can tell, but on the left-hand side there, we define some of the default services. Say, if you're playing in our opinionated stack, these are the non-negotiable things. We're giving you these. No team should be avoiding a secrets manager. We don't want secrets in code. So it's there, it's configured, use it. Cloud monitoring, cloud logging, cloud billing, things that bean counters need to keep track of. So all of those things just are provided. Some of the other services are optional. So depending on what type of app you're building, you may not need a cache. You may not need messaging. So you get the optionality there. So support standardization, but allow some customization is kind of the topic there. And then, of course, going through a portal allows us to do analytics and keep track of what kind of projects are being created, who's complying with what we're trying to provide. So, and with that, I'm going to hand it off to James.
Hey folks, how's everyone doing? I'm James. I'm a product manager here working with GCP and Cloud Run. And I have the pleasure of working with the Ford team and helping with the acceleration journey that they've been going through, as Todd mentioned, with their opinionated stack. As you can see, Cloud Run plays a large part in orchestrating a lot of the simplicity and the acceleration journey that Ford has built out with the opinionated stack architecture. So I'm going to give you a quick recap of Run before we get into some of the deeper specifics of how we've been helping them out with organizing the opinionated stack. In Cloud Run, we designed it with simplicity and velocity in mind. Cloud Run is a developer-focused product that allows for faster development in cloud-native workloads and applications. We find that customers choose Cloud Run because it increases innovation velocity and reduces the overall cost and risk. Cloud Run is specifically designed to make developers productive and allow them to focus on solving business problems. What does that mean? It means if you give us an OCI-compliant image, we can deploy it. If you don't, give us some source code and we'll build that as well. The key benefits of Cloud Run, I want you to remember 3 things. It's higher velocity and productivity. We see 95% faster deployment times compared to legacy platforms. We see higher reliability, 98% fewer interruptions to the service, and an overall lower cost. Auto-scaling is at the heart of the serverless philosophy. And with Cloud Run, you get the benefits of scale to zero, but also the hyperscale of not having to do capacity management and getting instantaneous scale-ups. Lots of great articles here that I'll point you to, but I'm not going to take up too much of that time. And overall, we see 3 things with Cloud Run. The experience, again, we demand as little as possible, focus on developing the core business value, and let us take care of the automation so that you can be at cloud scale while focusing on delivering the core value. On the runtime side, it's capable. As I mentioned, we give us an OCI-compliant container and we'll build it. If you don't, we also leverage open technologies like build packs to help you convert source code to a running code. And finally, on pricing, you only pay for what you use. And that's one of the great things about Cloud Run. If you have stable workloads, that experience spiky traffic or bursty traffic, we're there for you. If you have situations where you need to scale to 0, that's perfect. Because when you deploy to Cloud Run, we give you up to 100 milliseconds of granularity, and there's a perpetual free monthly tier and no flat fee. And with that, I'm going to hand it over to Gino, our senior engineering manager, to give you a deeper dive on how we've been customizing Cloud Run to help Ford.
Thank you, James. So hi, everyone. My name is Jinal Shah. I lead Cloud Run engineering teams at Google. And I have been working very closely with Ford. And I'm here to share how Cloud Run accelerated Ford's transformation journey to Google Cloud. So here are some of the key requirements that Ford was looking at. Better support for enterprise workloads. They have workloads, as Todd mentioned, are running on-prem. So they were looking for solutions that can manage and auto-scale these workloads so they don't have to do the infrastructure management, capacity management. They have hundreds and thousands of applications, so cost effectiveness becomes very important. Their applications and workloads were performance sensitive. I mean, who would like to wait for when you are buying a new car, that too Ford Mustang? Not me. As you can imagine, they had very strict security and compliance requirements. Majority of their workloads were deployed in multi-region, so they were looking at reducing those network complexity, such as automatic rollouts in multi-region. And as Todd mentioned, the heart of what they do, the ease of use, to enable their developers so that they can focus on developers' productivity, business logic, innovation, was something that was very important to them. So what were the characteristics of these workloads? Most of their workloads are Java workloads written in Spring Boot. And as they started onboarding these workloads onto Cloud Run, these containers were taking over 30 seconds to start. And what was happening was that these containers, the startup time, which is known as the cold start of the time, our auto-scaling behavior was not working as expected. And I'll explain you why. So cold start plays an important role in the auto-scaling behavior. So when the new request comes in, Cloud Run will try to send the request to already running instance known as warm instances. And when there are no instances available to serve the request, this request is put it in a queue known as a pending queue, while Cloud Run will try to bring those new instances of the application. In this case, the applications were taking 30 seconds, and the wait time in the pending queue was just set to 10 seconds by default. So now we were to ask Ford to rewrite 100,000 applications. That was not possible, and it's not even trivial. So we worked with Ford to improve our auto-scaling algorithms. So now, instead of the waiting time in the pending queue that was set to 10 seconds, we changed it to dynamically calculate based on the cold start of an application. We also made changes in how we roll out the infrastructure to reduce the maintenance interruptions. We also added the smarts in our algorithms, our auto-scaling algorithms, where we calculate where the latency is coming from. So for example, if latency is coming from downstream dependency, like connection to database or data store, scaling more instances doesn't help. With all these changes, I'm super excited to share that on Cloud Run, you can run any workloads, whether it's a cloud native, legacy, enterprise, with the container startup time of 4 minutes that covers majority of the workloads or entire workloads. So Ford, as Todd mentioned, was also looking at optimizing the cost and performance. So Ford used or leveraged the Cloud Run auto-scaling behavior that auto-scales the instances based on incoming traffic. And there are 2 settings available to do this. Min instances that determines the number of warm instances running, and max instances that puts an upper bound during the scale out event. So Ford pays only for the number of resources that its instances is using with these two settings. And what I mean by that is, let's say you have 100 max instance setup. It will, and you are only running 10 instances, then Ford only pays for those 10 instances and the resources it consumes when serving traffic. That's a huge deal. This helps them do a lot of cost management than always running infrastructure, and so. Some of their workloads, like test and dev, run only 9 to 5, they were able to scale down to minimum instances, and that also brought a lot of savings. Ford also leveraged Cloud Run's committed use discounts that allows you to reduce the cost by 17%. And not many customers know about this, so if you're not leveraging, reach out to your account team and take advantage of this. To improve the container startup time, Ford leveraged a CPU boost. And what this does is Cloud Run allocates 2 times the CPU, and that reduced the container startup time by 50%. And that solved a lot of the container startup times that was happening. Cloud Run is secure by default that met Ford's needs. Like Todd mentioned, like Secrets Manager was hard at what they do. There are lots of ingress controls, egress controls, very easy to set up and reduce their network complexity. And along with the secure features, Cloud Run has all the compliance certifications, as you can see here, that met their compliance requirements. So automation, how they were able to enable the EcoBoost or the Cloud Portal that we just saw. Cloud Run has every feature, every GA feature that Cloud Run has, it's also released on Terraform, the Terraform Cloud modules, so that it enables the automation, builds a portal like what Todd was showing, and that allows you to focus on the developer-centric mindset that drives the innovation. And with that, I'm going to give it to Jordan.
Thank you. Hi there, my name is Jordan DeBeer, and I'm one of the customer engineers helping to support Ford and their serverless workloads on Google Cloud. I want to share with you some of what made Cloud Run a great fit for Ford's application migration to GCP and what we had to do to get there. So a little fun fact, Ford actually owns the entire 19/8 network. This means that Ford's network has grown to serious scales over their long history and resulted in a different architecture than most other enterprises. One particular benefit of Cloud Run that we were able to rely on is abstractions built into Cloud Run itself to solve a majority of our networking complexity. Ford wasn't required to decide on what zones to deploy to or which subnets to use, so tasks that previously required centralized management, like IP planning, to scale out instances are handled for us, reducing the toil on Ford operations teams and developer productivity. Network ingress controls can be changed with just one setting versus having to work across those organizational boundaries to change things like firewalls and routing rules and et cetera. We're able to use invoker privileges to decouple service connectivity from authorization, allowing for applications to be secured via IAM. The majority of Ford applications on Cloud Run follow the internal web application pattern, which looks a lot like the 3-tier web app, except supercharged by Cloud Run. Applications are fronted by Apigee for authentication, centralized security controls like logging, and more. This type of architecture is a great fit for Cloud Run, given the security controls mentioned earlier, as well as the automated scale-in and scale-out capabilities. Prior to Cloud Run, internal apps had fixed infrastructure costs throughout the day, and even if there were 0 users accessing the app, it was still running and incurring cost. With Cloud Run being able to scale to 0, applications that only see traffic during certain windows do not incur these fixed baseline costs. This also means that as traffic spikes, the service itself is able to provision more resources, and the developer doesn't have to build complicated scaling logic themselves. And in order to accelerate a large enterprise like Ford moving to Cloud Run, both Google and Ford had to come together to build tools and processes to support developers writing code for vehicles across the globe. Ford runs and operates Cloud Run from a central team, so we needed to build various mechanisms and processes to support the user base. Things like a support system for users who need help, methods for gathering feedback to improve, and observability so we could objectively measure our progress and react to large-scale events. As Gino spoke about earlier, we also worked with Ford to build some features in Cloud Run to increase reliability for the applications that had those high startup times. We wanted to bring value to developers every step of the way, so not only do we build infrastructure components, but also the opinion on how it should be consumed, so there is a clear vision from the language to the framework to the runtime and the architecture. Of all the things these teams have done, I think the one I'm most proud of is all the effort from all the people of Google and Ford who came together to accelerate Ford to where they are today. So thank you all out there for helping that. And I'd like to welcome Todd back.
So a few bullets on what the wins were of our work together in our collaboration. So 2023, we moved hundreds of apps. I put it in air quotes because an app might have many, many components. So our internal use of the term app is different than others, but there was a lot of work done. But the win for us too, though, is that the work we've done has prepared us for what really is going to be an exponential growth in the amount of workloads and apps that we're going to have to move in 24 yet and beyond. Absolutely, automation was a win. Hopefully you caught that from what I shared earlier. Getting developers get their precious time back on the keyboard developing code as opposed to dealing with manual processes was a key win for us. And internal best practices. I mentioned diverse technology footprint at Ford. Of course, we would like that to look a little more common because I think we all can go faster when things are as common as possible. So those clear definitions of best practices, patterns, the opinionated stack were clearly wins on this journey. What's next, I think, and I'm going to stay up here.
All right, so what's next? What's coming in 2024? So as Todd mentioned, more workloads are coming to Cloud Run, different kinds of workloads like batch and such. That Cloud Run jobs, I don't know if you have heard about those, long-running jobs, that's something that we are currently exploring. There are new features, lots of security features, container threat detection that exploits the containers and vulnerabilities in those, push it out to the Cloud Security Command Central, and this is one of the big asks from Ford. So we are currently working in the development phase for this feature. There are other features like sidecars, multi-containers, Cloud Service Mesh. We just announced preview that we are working to see how Ford can improve the service-to-service communication and other requirements that they have there. And direct VPC ingress that we also are going to be announcing soon is going to bring 2x throughput, reduce their cost and performance and improve their performance and things like that. So I'm really looking forward to 2024 and beyond. And with that, I want to say huge thank you to Ford. Like one of my proud moment is like Ford is a huge company and so is Cloud and Google, Cloud Run, and we all came together to make this transformation journey fun. We worked as one team, like several meetings, and sometimes we forget which team we are on that. So that's a very proud moment for me to bring this transformation and able to do this with Ford. And Ford really helped us make our products better. So with that, we would love to hear your feedback on this session or in general. So here is the code. Please take a look at this.
Thank you, everyone.
And thank you for being here.